We're going to first talk about, we have this word here, polynomial. We need to figure out what a polynomial is, and we're going to start by looking at a monomial. And a monomial is a number, so it is a number, a variable, or the product of a number and a variable. So it's like a single term in a sentence, kind of. Like if you have an entire word or if you have an entire sentence, that's your polynomial. The singular word is going to be our monomial. So a monomial is a number, a variable, or the product, as in we're multiplying things together, of one or more variables with only one number. And that is a monomial. All right, and every single monomial has a degree. So the degree of a monomial is the following. So the degree of a monomial is the sum of the exponents in the monomial. And so constants, so any whole number, they just have a degree of 0. And so this degree term is important for helping us order and make nice looking polynomials. And we have to remember this is going to be the sum of the exponents. So I'm going to give you some examples now of what a monomial could be. So if we put a monomial right here, right, here's what a monomial can look like. It could be the number 10. 10's a monomial. It can be the term 3x, right, because that's a product of one variable plus a number. We can add some more variables. 1/2 a multiplied by b squared. And then finally we can take something, like a negative number, 1.5 and m squared. So every single one of these is going to be a monomial, and each one of them has a degree. And to find the degree, we need to take the sum of the exponents. And if there is no exponent, right, like a constant, and a constant's a whole number, that's just going to be a degree of 0. So this number 10, that's degree is going to be a 0. If we look at 3 and x, right, just disregard the 3 on this and look solely at the variables now. If you see no variable, it's 0. If you see a variable, then add the sum of the exponents. Right, and every single term has a hidden exponent there. So if you have just an x, its exponent is 1, because x to the first is just equal to x. Right? On a, we have 1a and 2 b's. So we're going to take 1 plus 2, and that's going to be equal to 3. All right, and then finally this guy down here is just a 2, so that's going to be 2. All right, I'm going to give an example now of some things that are not a monomial. And then, we'll put the reason over here too. So let's first take a look at 5 plus x. That's not a monomial because there's more than one term. All right, what if we look at 2 divided by n? Right? We defined a monomial to be the product, not the divisor. So we cannot have a variable in the denominator. Right? That's a negative exponent. What about something like 4 to the 8th power? And I'm going to read 4 to the xth power. Right? That's not allowed either because we don't want a variable and an exponent. We can't have a degree of this monomial. And then finally, what if we have something like x to the negative first? And just like 2 to the divided by n, we're working with a degree less than 0. So everything here on the left, those are all monomials. Monomials look very clean. This weird stuff on the right, we're in not a monomial land. All right, so we're going to start out by just finding the degree of different monomials. We're going to do some practice here. So we're going to find the degree of each one of these monomials. So we're going to find the degree of each monomial. I'm going to list them all out first so you can start to think about what they might be in your head. Maybe you're taking notes alongside of me at home. So the first one's 5x squared. The second one is negative 1/2 x multiplied by y cubed. The third one is going to be 8x cubed y cubed. The fourth one is just going to be the number -3. The fifth one is going to be -3 times x to the fourth. The sixth one is going to be 7c cubed multiplied by d squared. The seventh one is going to be 5/3 multiplied by y. And the eighth one is going to be -20.5. So first off, each one of these is a monomial. If we scroll back up to this table, they all follow the rules there on the left. And each one of them is going to have a degree. And so when we look at the degree, we want to look at the variables. So ignore the number 5 here. Just look at this x squared. And simply look at the exponent. So whatever the exponent is, if you only have one variable, that's our degree. So that's a 2. Right? The second problem here, -1/2 x y cubed, we have two variables. So here, an x is going to have a degree of 1, and a y cubed is going to have a degree of 3. 1 plus 3 is equal to 4. We're going to ramp things up on number 3 because we're going to have 3 x's, and we're going to add 3 y's, and so that degree is going to be 6. -3, simple enough, that's just going to be a degree of 0. Every constant has a degree of 0, and why we're looking at that, number 8 also is just a whole number, or it's not a whole number, it's a -20.5, but that's also going to have a degree of 0. The rest of these all have variables though. So going back in track now, number 5, there's only going to be 4 x's there, so that's going to be a degree of 4. C, we're going to have 3 of those, and D, we're going to have 2 of those. Add 3 plus 2 together, that's going to be equal to 5. And then finally, this last one, there's only one y there, so that's going to be having a degree of 1. All right, so a monomial is every single one of these. Right? Every single one of those numbers is a monomial. Every single one has a degree. And when you combine multiple monomials, that's where you get a polynomial. Right? The word poly means multiple. So a polynomial is a monomial. So it can just be a monomial, or the sum of monomials. Right? So each monomial is called a term. So the word monomial and term is basically interchangeable. if your polynomial only has two terms, is just going to be called a binomial. The word of bi means two, and so if you have two terms, that is a binomial. Likewise, if you have three terms, a polynomial with three of them is going to be called a trinomial. And then if you have, four or more terms, you're not going to have a quadromial. That's not really that fun to say. So anything with four or more terms, that's just going to be a polynomial. And just like a monomial, every polynomial has a degree. So the degree of a polynomial is going to be the following. So this is going to be a vocab word. The degree of a polynomial is the greatest degree of one term. So before we continue on here, if we scroll back up to this example we just did, where we found the degree of each one of those monomials. The monomial in the polynomial with the greatest degree is the degree of the entire polynomial. Right, so for this example, number 3 here has a degree of 6. So that would be the degree of this entire thing if we added all of those together. So a polynomial is written in standard form when the exponents decrease from left to right. So you write the biggest degree first, and then the next biggest, and then the next biggest, and then you have nothing left at the end. All right, and the very first coefficient is called the leading coefficient. All right, so I'm sorry I'm throwing a ton of vocab at you, especially because this is the first day that we're doing online classes, but unfortunately it just worked out that this was the start of a new section. All right, and I need to really emphasize now all these different terms that I just gave you, because there's a lot going on here. I will admit that. So if we write the polynomial 2x cubed plus x squared minus 5x plus 12. This whole thing is a polynomial. Each one of these individual terms is a monomial, so that's pretty straightforward. All right, and it's also written in standard form. So that whole thing's written in standard form, right? The degree of this guy is the degree of the entire polynomial, right? So that has a degree of 3. X squared only has a degree of 2. 5 to the x has a degree of 1. And 12 has a degree of 0. So notice it goes 3, 2, 1, 0. We write it from largest to smallest, right? That's just decreasing left to right. All right, this term at the end, this 12, that is called our constant term. And this coefficient on the front, this 2, that's called our leading coefficient. right? We're just breaking down the individual components of these polynomials because in a couple of, like next Monday, we're going to start getting into factoring. And when we get into factoring, we need to know all these different terms because it's going to allow us to factor easier. So I'm going to give us a polynomial now that's not going to be written in standard form, and our goal is to write 15x minus x cubed plus 3 in standard form. So I'm going to rewrite this polynomial, 15x minus x cubed plus 3, and we're going to identify the degree of every one because our goal is to order them by degree, and then we need to order them from the largest degree to the smallest degree. So if we look at 15x, the degree of that is just equal to 1. If we look at negative x cubed, the degree of that is equal to 3. And then finally our constant term here, 3, the degree of that is just going to be equal to 0. So now you go through and look, which is the largest degree? Well, the degree of 3 is the largest, so we're going to put that in front. The big thing is here, we need to keep the negative with the x cubed, right? You need to start realizing that a minus sign goes with a negative, right? Minus and negative is kind of interchangeable, right? So this is a negative x cubed, right? Keep the negative with negative x cubed. Big thing, right? It's okay if you make mistakes. I made a ton of mistakes. I continue to make a ton of mistakes. Negatives are just that little minute problem that you always run across. So it's okay if you make the mistake, just realize that you made it. Right? Then our next largest degree is this degree of 1, and then we're going to finalize it out with the degree of 0. So we got a negative x cubed, plus 15x, and our 3 is going to just drop straight down. So now we have ordered this thing from smallest to largest. My bad. We ordered it from largest to smallest, the biggest degree to the smallest degree, and this now is written in standard form. All right, so now we're going to go through and we're going to identify some polynomials by type. So is it a monomial, a binomial, a trinomial? And we're also going to write them in standard form as well. So we're just got a whole bunch of stuff going on. And so we're going to write in standard form. And we're going to classify it by the type. And so we're going to do 3 of them. Our first one is going to be negative 3z to the 4th. Our second one is going to be 4 plus 5x squared minus x. And then c is going to be 8q plus q to the 5th. All right. I'm throwing in these other variables just so we can get accustomed to seeing variables other than x. And so now we're going to make a table. We're going to start with our original polynomial here. We'll give ourselves plenty of room. And so we have a negative 3z to the 4th, a 4 plus 5x squared minus x, and an 8q plus q to the 5th. And we're just going to work through each one of these and write them first in standard form. Then we're going to identify the degree of the polynomial. And then we're going to identify the type of the polynomial. All right, and first we need to identify, before we do any of that, this polynomial, negative 3z to the 4th, is only one term. Right, so it's a monomial, first of all. And because it's a monomial, it's already written in standard form. We can't change negative 3z to the fourth and move it in any position. And then finally, its degree is going to be the degree of that exponent of 4. All right, why don't we take a look at this next one? I feel like it's a little more complex. 4 has a degree of 0. 5x squared has a degree of 2. And negative x to the first has a degree of 1. So we're going to identify which term has the largest degree. And that's going to be 5x squared. So we're going to write that one first. Next, we're going to identify our next smallest degree. That's this degree of 1 right there. So that's going to be a negative x. Remember to keep the negative with the x. And then finally, we will put on the constant at the end. So we have 5x squared minus x plus 4. And the largest degree is the degree of the entire polynomial. So that would be this 2 right there. And because there's 1, 2, 3 terms here, that's going to be a trinomial. All right, let's do this last problem. This first problem only has one q, so it has a degree of 1. This last one has q to the 5th, and so that's going to be a degree of 5. 5 is greater than 1, so we will write our q to the 5th first, and follow that by our 8q. The degree of the largest degree is the degree of the entire polynomial, so that's going to be a 5. And because there's only 2 terms, that's going to be a binomial. Right, so it's pretty important to be able to identify the degree of certain terms, be able to organize them into standard form, identify the degree of the entire polynomial, and also know its type. So we first introduced monomials, then we identified how we can sort some polynomials, identify them. Next, we're going to look at what happens if we try to add 2 of the polynomials. So to add 2 polynomials, it's pretty straightforward actually. You add the like terms. So I'm just going to, dive straight into an example here. If we have the polynomial 2x cubed minus 5x squared plus an x, and we're going to add to that 2x squared plus x cubed minus 1. We're just going to simply add our like terms together, like we've been doing all year. Nothing is going to change compared to normal. All right, so first thing we're going to do is drop the parentheses on both of these polynomials. So just 2x cubed minus 5x squared plus an x plus 2x squared plus x cubed minus a 1. And then we just need to go through and identify like terms. So what I like to do is I start with this first term, 2x cubed. And I look for another x cubed, right? So that doesn't have one, that doesn't have one, that doesn't have one, there's one. So 2x cubed and x cubed, those are the same. If we add 2 plus 1, that is going to be a 3x cubed. All right, next I'm going to look through for 5 squareds, or not 5 squareds, x squareds, and there's another x squared right here with 2x squared. And now we need to take a negative 5 plus 2, and negative 5 plus 2 is a negative 3x squared. And then we'll go through and look for another x. Well, this is the only x, so we'll tack that x on at the end. And then finally, we are left with our lonely number 1 back here, and that is just going to be a minus 1. So now that highlighted polynomial is our two polynomials added together. And notice it's already in standard form. All right. Most of the time your polynomials will be written already in standard form. So that's really nice for you. Doing another problem. Oops. We're going to look at 3x squared plus x minus 6 plus x squared plus 4x plus 10 and we're going to see what happens when we try to add these two together. And then nothing's going to be too different. We're going to drop our parentheses, so that's just going to be 3x squared plus an x minus a 6. Drop our parenthesis on the second one, so that's going to be x squared plus 4x plus 10. And we're going to do the same thing. So I'm going to look for some x squareds, and there's one right down there. If we take 3 plus 1, that's going to be 4x squared. Next, we're going to go through and look for plain old x's. There's an x right there, 4 more x's down there, so 1x plus 4x is going to be 5x. And then we have our constant terms, so this is a negative 6 plus a 10. A negative 6 plus 10 is a positive 4. All right, so that's an example of adding two polynomials. You just drop the parentheses, add them together. The big thing you need to do is identify this plus sign here in between the two, right? Because you can either add polynomials, subtract polynomials, multiply polynomials. That's what we're going to be doing in a couple of weeks, and then divide polynomials, and we won't do that. All right, so always look at the order of operation there in between your two parentheses. These were both a plus. But what happens if we try to, I don't know, subtract two polynomials? So to subtract, it's going to be a little bit different. We're going to multiply the second polynomial by a negative 1 and then add. And the reason why we're multiplying the second polynomial by a negative 1 and then adding is because that's actually what you're doing when you subtract. So just real quick, taking aside, if we look at like 5 minus 3, right, that is equal to 2. 5 plus a negative 3 is also equal to. So to subtract our two polynomials, we're going to take this second route right here. We're going to multiply everything by a negative 1 and then add. So I think this is better seen straightforward as an example. So let's look at 4n squared plus 5 minus a negative 2n squared plus 2n minus 4. And so we can identify that in between these two polynomials is indeed a negative sign. The only thing different between these top problems is there's a plus sign. These bottom problems are going to be a negative sign. And so we're going to distribute this negative 1 to each term inside this polynomial. And so that's going to be 4n squared plus 5. Nothing happens to the first one. And then a negative multiplied by a negative is a positive 2n. And then a negative multiplied by a positive is going to be a negative 2n. And then a negative multiplied by a negative is going to be a positive again. And then once you've done that, you're in the clear. You just add your like terms, combine like terms. So n squared and n squared, we got 4 on the left. We got 2 in the middle here. So that's going to be 6n squared. We look for an n's, no n, no n, no n. Here's an n. And so there's only one n, so we're gonna leave that as negative 2n. And then we just put our constant terms on the end. So 5 plus 4 is going to be plus 9. All right, let's do another problem. We'll get 4x squared minus 3x plus 5 minus negative 3x squared. Oh, not a negative 3x squared, sorry. Just a minus 3x squared minus x minus 8. All right, and here's the big problem that I see with these. We recognize that there's a negative here. We put this negative on this first one, and then we just don't do it for the other problems. And I'm saying this is what I see a lot because I did this a lot. I still do this a lot. It just takes a lot of practice to drill this into your head. So we're going to write down our first term over here, 4x squared minus 3x plus 5. All right, this negative is going to be distributed to that 3x, so that's going to be minus 3x squared. This negative is going to distribute to the negative x, so that is going to be a positive x. And this negative is going to distribute to the negative 8 to become a positive 8. And then we're just going to combine our like terms to finish things out. So we got a 4x squared here, a negative 3x squared there. 4 minus 3 is just equal to a 1x squared. Negative 3x plus an x is going to be a negative 2x. And then finally, 5 plus 8 is going to be equal to 13.